Yeah, I think that is working. Anthony, shout if this is not working, but I think it is. Right, welcome everybody. Thank you all for joining us and making your way down here today. I hope you're all doing well, both mentally and physically, during this sort of crazy time we're going through. Yeah, hopefully we can make things a little bit brighter this evening with some interesting talks we got lined up. So we have three great speakers tonight. Firstly, Jenny will be sharing her process of building a web game using no game engines or libraries, which sounds quite crazy. George will then be talking and giving us a brief overlook on the do's and don'ts of using computer vision techniques for art installations and commercial projects. And then finally, Cassie will be showing us some of her SVG magic and specifically on how to make illustrations less flat. Each talk will last about 20 minutes, and during that time, please post any questions you have in either the YouTube chat or the Zoom chat if you're on Zoom, and Anthony will select a few of them and we can ask them at the end. So I think we're about ready to start our first talk. If I can just make sure I push the right buttons. Right, I'm going to transition over to here.
Hello. Cool. Can you see my slides okay? Cool. So, hi everyone. My name is Jenny Robertson. I am a software engineer at BBC Sounds, and I developed the Sounds website using JavaScript and React. And my presentation is Peckin Pixels, my journey creating something from nothing. So I'm going to go through the process of how I made my game, Peckin Pixels. So I'm going to go through my inspirations and why I decided to make a game. I'll show you a quick trailer, and then I'll tell you why I use Canvas and show about how I made the graphics and some of the coding. Then I'll explain how the release went, and you can ask me any questions. So why did I decide to make a game? Well, I'm just one of these people that needs to have a creative hobby for me to enjoy myself. And it also let me learn a lot more about JavaScript, which I use at work. And it gave me a break from using frameworks and coding libraries, which I use at work, and I didn't have to have any code reviews. And I just find it really fun. Like sitting at home and just animating a chicken is something that is just great fun to me. And for my whole life, I've always wanted to release the game. So it's basically a life goal achieved. So I'm now going to play you a short trailer of my game so you can have an idea of what it's all about. So just to summarize what you saw in the trailer, in Peckin Pixels, you play as a farmer who is looking after his chickens or her chickens. So you start off with one single chicken, which you have to feed. And then once you've fed it, it will lay an egg. and you can either sell this egg or raise it as a chick. And these chicks will grow into even more chickens. So the more you play, the more different colored chickens you unlock. You unlock different foods and power-ups that you can buy for them, and you get achievements. And also you can dress up your chickens in funny outfits. So my inspirations for making this game, first of all, is a game called Stardew Valley, which I played hundreds of hours of. It's a pixel farming game, and that was sort of a really big inspiration because I just found that game so fun. Another inspiration is Tamagotchi, which is a little handheld game that I played when I was younger. And it's where you have a little pixel pet and it has sort of stats like hunger and health. And then my favorite genre of games was always games where you have to manage things. So Theme Hospital, you have to manage the money for a hospital. Roller Coaster Tycoon, manage a theme park. And then my final inspiration was Overcooked, because I really wanted my game to have a sort of stressful arcade kind of feel to it, which is definitely what Overcooked has. So the stack, or the technology that I used to make Peckin Pixels, was HTML and JavaScript and CSS. I used Canvas to render the game. I used Webpack to make my files easy to release. And I used Babel to make sure that my game would run on older browsers. So why did I use Canvas and no game engines? Well, I could have used a game engine like Unity, which would have given me lots of physics engines and functions that I could have used. But I wanted my game to work on mobile and all browsers. And sometimes you would get this pop-up saying that you had to download the plugin, which wasn't something I wanted. I could have used Flash, but unfortunately Flash is being killed by the browsers soon, so that wasn't an option. So basically, making something from scratch meant that there was nothing to Google because I had to work out all myself. It gave me full control over everything. It helped me learn more JavaScript, and it meant that it worked on all devices, which was important because I wanted all of my family and friends to be able to play it. And it was just more of a challenge having to recreate everything from scratch. So what is Canvas? Canvas is an HTML element that lets you draw graphics on the web. It's basically just like a real life canvas. So it's got some different functions you can run on it. So first of all, there's draw image. So you can just draw this little mouse here. You can add text, you can draw shapes, and you can clear it. It has a few more functions than this, but this is the basic functionality. So now I'm going to go a bit into how I made the graphics. So I made loads of sprite sheets. So a sprite sheet is basically where you take every frame of an animation and you put it in a big grid like this, and that means that I can load it into my game easily. So on the left, we have my chicken sprite sheet. So the top two rows, we have the chicken walking. These rows, we have the chicken eating, the chicken sleeping, and the bottom two rows are the chicken laying an egg. Here we have the chick. This sprite sheet shows a piece of corn in all the stages of being eaten. And here we have one of the eggs. So I created all of my graphics pixel by pixel in Photoshop. And it has a really useful animation tool, which lets you make simple animations. It's not as advanced as Flash, but it basically lets you just add a new frame, change the pixels a bit, and create a little simple animation like this at the bottom. Now, I needed a way to get this animation into a sprite sheet form, but luckily there is a script which I found called Sprite Sheet Generator, which generates a Photoshop animation into a sprite sheet like this. Another thing that I had to overcome was that I had made this lovely sprite sheet and it was quite complicated, but I wanted to have loads of different colored chickens. Now I could manually recolor the chickens in Photoshop, but it took quite a long time. And I realized that if I wanted to change the animation, so maybe add another row, I would have to recolor all of the sprites all over again. The solution I found for this was a JavaScript library called PNG.js, which lets you recolor PNGs using code. So to use it, I created a template chicken sprite sheet with these special colors, and I slotted all of the colors that I used into this JavaScript object. So you see we have the main color, which is the background of the chicken and the shadow. We have the color of the top of the chicken and the yolk and all the colors that are in my sprite sheet. I then created a large array of JavaScript objects, which had all of the colors of the chicken that I wanted to be output. So each of the colors in the template corresponds to a color in the chicken that I wanted. So you can see here I've put in all the colors for this purple chicken. Then once I had my large array of chicken objects, I just had to run a single command, and PNG.js would recolor the template and name the file the color that I wanted. So that made it really quick and easy for me. Now I'm going to talk a bit about more of the coding I did to make the game. So I'd made my fancy sprite sheets, but now it was time to make the animation play like this. So in order for a sprite sheet to play as an animation, you have to render each individual the animation one at a time. So this frame, then this frame, then this one, and so on, and looping round. And this causes the animation to play. Now I said earlier how Canvas has a draw image function, but I needed to only draw a small portion of the sprite sheet so I could play each frame one at a time. So the way to do this is the second parameter for draw image says where you can start drawing from. So if I wanted to draw this frame here, to work it out, it's the width of one of the frames, so that's 100 pixels. And I times that by the frame I want, which is frame 3, which gets me 300 pixels. So putting this value here starts drawing just this tiny part of the sprite. And then the X and Y gives all the other values. So then in my game, all I have to do is increment the frame, and it will keep drawing a different part of the image and create this sprite sheet animation. So one of the biggest challenges that I had to overcome when making this game was, how do we know which item the mouse is over? Now, normally in a browser, it would do this automatically. So if you had a button element on a website and you moused over it, then the browser would change your mouse to the little pointer icon. However, as Canvas is basically just a big image, I had to do this manually. Luckily, Canvas has a function which can tell you about whether the pixel you're looking at is transparent or solid. So we want our mouse cursor to only change pointer if we're over a solid pixel and not change if we're on a transparent one. So here we have our lovely picture of the mouse. So say we want to test this pixel, we put in the X and Y coordinates of this pixel, and this is the result that getImageData will give us. So we have 255, 255, 2550. The first three numbers represent the color, and then the last number represents the alpha, or how solid it is. So this has come out as 0, which means that the pixel is transparent, so we don't need to change the cursor. We then run the function again on this pixel, and we see that the final is 25, which is the maximum number, so that means our pixel is solid, and we should change the cursor. However, there is one issue with this, which is that if we have background color, if we test this pixel again, it's come out as a solid because it's seeing the back color and thinking that it's solid. As my game always has a background image, issue. The way I found to get around this is to use something called a ghost canvas, which is a second canvas that the user can't see. So say we have these two chickens and we want to know which chicken our cursor is over. So first of all, we get the canvas and we draw each chicken one at a time onto it and see if our cursor is over it. So first of all, we draw the orange chicken and our mouse is at 10:15. So pixel at 10:15 and we see that there's nothing there. We don't change the cursor. We then draw the red chicken and we test at 10:15 again, and we see that it has a solid pixel underneath it. So we do change the cursor. Another part of the game which I found really fun to develop was the AI of the chicken. So this is a little snippet of how it works. So you start off with the chicken being idle, and then it checks whether it's broody, so if it wants to lay an egg, basically if it's had food or not. So if it is, then it lays an egg and it goes to sleep. Then if it's not broody, it checks if it's hungry, which is whether its hunger is over 50%. And then it finds the closest food and it eats it. If it's not either of these, then it just finds a location on the grass and it walks towards it. Then it waits a random number of milliseconds, so all the chickens aren't moving in the same, and it does it all again. And that's all it is for the chickens. So now I had created my game, it got to the bit that I was least confident with, which is releasing it. So I decided to release my game on a website called itch.io. Itch.io is a non-profit website which lets you host games for free. It doesn't make any money off them, and it has quite a large customer base. So I chose to release it here because it was free, and I thought lots of people would be able to see my game. So I released it, and there were some good things that happened. So first of all, after I was expecting that I would only get maybe 100 plays of my game, and that would have made me happy. But then someone on the website Reddit found my game and posted it to the subreddit Web Games, and that boosted my views by thousands and thousands, which, as you can imagine, made me extremely excited and made me feel like my game was a success. But then the official Twitter for the itch.io website retweeted my game, which was obviously even more amazing, and I'm now completely overexcited, and that got me even more views. And a website called Crazy Games approached me and asked me if they could host my game. And the good thing about that was that they give a revenue share from the ad revenue. So from that, I've earned about £100, which is great because I wasn't expecting to earn any money at all. I think my favorite thing was when people started playing my game and they would send me screenshots and send me comments. So here's someone who sent me a screenshot of their brown chicken collection. Here's someone who completed the game, so they've got the award, and they've got loads and loads of rainbow chickens, which must have taken them ages. Someone who made loads of pirate chickens, and here's someone with cat ears that they made. And all of these screenshots and lovely comments honestly just made it all worth it for me. An even better thing that happened was that some YouTubers found my game and made some playthroughs of it. Now, I'm used to seeing really big popular games being played by YouTubers. So the fact that YouTubers I didn't even know found my game and decided to make a video was fantastic. I was also featured on the podcast This Week in Video Games, which gave me a little boost, and it was just great fun. However, not all of it went perfectly. So here are the bad things that happened during the release. So if you Google Peckin Pixels, you will find about 100 results, which are crazy games, not itch.io, but websites had stolen my game. So here's one of the websites. So this website is now making ad revenue off of my game that I made just because they've stolen the code. Here's another website that stole it. Here's another one. There's just tons and tons of them. So as you can imagine, that made me a bit annoyed because they're making money off something that I did. I tried to stop this by adding a little check into my code. So what it would do, it would check the URL that the game was currently on, and if it didn't match one of my accepted websites, it would display this message. However, the problem with this was that my game had already been released without it, so they just continued to play the game and download it with that original version, which didn't have the check. I did try and email some of the companies, but none of them responded. But a funny thing that happened to do with the stealing was that this website called Arcade Pre-Hacks, who also stole my game, decided not only to steal it, but to hack into the game and edit the code. So if you look down here, it says, press 1 for instant broodiness, press 2 for no hunger, and press 3 for money. And this website up here made it so that it was exactly the same, but it had basically 9 billion money. So I actually found this quite amusing because not only had they stolen my game, but they thought it was good enough that they would actually edit the code and add some hacks. So that sort of made me feel quite proud that people had actually bothered to do that. So overall, what did I learn from making this game? First of all, building a game with no game engine is fun, but it is really time consuming. It took me about 2 years to make this game, although I was only doing it 1 day a week. Add some protection to stop your game from being stolen. So I don't know if I did my protection right. So if anyone has any tips on how to stop your files from being stolen, then let me know. While you're developing something, post about it on Twitter and use some of the hashtags such as Screenshot Saturday, because people click on those hashtags and you get more viewers. Find websites which give you ad revenue so you can earn a bit of money. But my biggest tip is definitely make a game that you would enjoy playing yourself. So whenever I was thinking, what new feature should I add? I basically just asked myself, what would I want to play in the game? And then I got my answer. So thank you very much for watching my talk. My game company is called Waving Walrus Games, I'm Jenny Galaxy on Twitter, and you can play the game on wavingrwalrus.itch.io, or if you want to give me some revenue, then play it on Crazy Games with your ad blocker off. So thank you so much. Does anyone have any questions?
Thanks. Yeah, so we have a few questions on YouTube. One of the questions is from Jeremiah. He says, when you're using PNG.js, this is a bit of a technical question, how do you define which pixels are impacted to which parameter? Do you have different layers of PNGs?
So basically, how I did it was it did the whole image, and it was like every single pixel that is this exact color, then change it to this new color. So I made it so every element in the chicken was like a different color. So all of this exact hex value would become the new hex value in the final chicken.
Another one from YouTube is from Valstorm Chaos, so usernames. What are your thoughts on native browser DRM? Because I know that's something that browsers have thought about adding for certain things, but what are your thoughts on it?
Well, obviously, if there is a way that I could have stopped my game from being stolen, I think that would be really good. But then at the same time, it is quite fun when you get to inspect a website that you like and see how it was made. So you don't want to make the web too restricted. But yeah, it would be good if I could have stopped people from stealing my game somehow. So yeah, if anyone has any tips, then let me know.
I have a question for myself, not on YouTube, just in real life. So when I'm working on personal projects, sometimes it's like really hard to take a project from 90% to 100%. It's like the last 10% is almost another 100% to complete. How do you like get from to completion, and like how do you decide when a project is ready to when it's finished and ready to release?
Yeah, I definitely had that problem. Like towards the end, I was I didn't want to see the chicken anymore, and I just wanted it to be released. And then I would think it was nearly done, and suddenly a massive bug would come up. But I think it's just because I had spent so long on it that I just sort of said that I wanted to try and release it before Christmas. So I gave myself a deadline, and I don't know, I just wanted, when I was developing it, I had shown some of my colleagues and friends before it was finished, and they sort of kept nagging me like, oh, when's the game going to be released, Jenny? I've been waiting 4 months. So that also helped for me to be motivated.
Cool. That's all the questions from the chat. Over to you, Dan. Thank you, Jenny.
Thank you. So it wasn't actually anything to do with the canvas. It was actually taking my template image and just outputting more images. So yeah, you could use it for any image. It's nothing to do with canvas. It's pretty useful.
I switch over to that channel so people on YouTube can hear me as well. Sorry, YouTubers, if I was quiet. Anthony, you're supposed to remind me of this stuff.
Oh, Dan, remember you got to turn the mic on.
Ah, thanks, mate. Yeah, so we're gonna take a couple of minutes break. Yeah, I'm getting messages saying we can't hear. Yeah, sorry guys, you're a little bit behind. Sorry, no offense. Yeah, we're gonna have a couple of minutes break and literally 2-3 minutes. Go grab another beer or glass of wine or whatever you're drinking. It's on me, and we'll see you in a couple of minutes.
Okay. Are you on homie?
To unmute myself on YouTube. I'm going to remember to do that like one of these days before I start talking. Right, hello YouTubers as well as Zoomers. Right, we're going to now hand over to George. George, I think you have all the power to go full screen, hopefully, and share your screen and tell us some amazing things. Yep, we see your screen there, George. Yep.
Perfect. Okay. Hi, I'm George. Get back to the new stuff. So I'll talk about places where I've been working and where I'm working at the moment. So for the past 8 years, I worked at a company called Hersheyman, which is a design technology consultancy that focuses more recently on premium brands and creating experiences. But it has its history in making experiences for like design galleries, art installations for museums and other cultural institutions. I think actually I'm just going to kill the audio and leave a show reel going so you can get a feel for the type of project. But yeah, my main role is mainly being the software guy, so acting as a bridge between the lovely designers and like product designers, interaction designers, all sorts of designers that came up with all this crazy, beautiful concepts, and the electrical engineer that would make custom circuitry to drive many lights and motors and things like that for experiences. So it was an interesting position to be able to talk both languages and bridge the design world and all the amazing aspirations with the realities of the physical constraints. Main focus being on physical, tangible experiences and marrying them nicely with digital elements. So recently, I've changed gears a bit, whereas before I used to work on many kind of projects throughout the year. Now I'm, I guess, your typical software engineer solving bugs and focusing on one piece of software. So I work at a company called Skies, and it's different in the sense that it's a product company, so they sell media servers, usually used for big events, concerts, things like that. And one thing in particular that I'm going to be focused on there is a product they call OmniCal, which essentially use the projectors to 3D scan a space and then semi-automatically do the projector calibration that can be used to easily map things for big projects that use hundreds of projectors. So I'll leave their show reel going as well, killing the audio. Yeah, so it's a very sort of big different shifting gears, I suppose. But the thing that is constant across these different projects is interest in computer vision, which I'm going to talk about. Like, what is it? Where does it come from? What's the point of it? I guess. I mean, where is it used? And more importantly, how can we have fun with it in a creative context? Whereas more normally you think of computer vision as I don't know, something that used as autonomous vehicles and maybe UAVs and some other industrial uses. So yeah, that's roughly the agenda for the talk. It's going to be very sort of random. There's some sort of structure to it, but I'm going to go back and forth a little bit and if you see anything interesting or if you want to learn more about it, because there's only so much I'll be able to cover in the amount of time for this presentation. Pop that in the chat, and after the presentation, I'll be able to talk in more detail. So, funny thing about computer vision, it started a long time ago, and it started off as a summer project at MIT by a very clever person named Marvin Minsky. So the funny thing about it is the assumption that, yeah, this is just a summer project. We can solve all there is to solve about computer vision in a summer. And that project that started in 1966 is still going now in 2020, and I'm sure there's many problems to be solved. So even back then, they're looking at trying to help computers make sense of what they see. Yeah, so what is computer vision? In short, in layman's terms, I'll describe that as trying to analyze images to extract more meaning out of it than just a raw pixel. So earlier on, there was talk about canvas and accessing pixels and colors, and that's great if you want to synthesize pixels, and it's great if you want to start analyzing shapes, but then there's more data that you can understand from images. So this is an example. This image, it's from a paper from 1973, which you might now recognize as something that's already kind of solved and implemented as a Snapchat filter. So trying to understand if there is a face in the image, which way is it looking, what are the facial landmarks, parts of the face, which then can be used to augment the face. There's another project that I found very, very interesting, especially kind of jumping in from the computer science nerdy side of things into more, I guess, the more artistic side of things. So there's always been a collaboration between computer science and arts for a long time. It's just that now it's more commonplace than it was, whereas before, only a few labs in the States that would usually be part of large universities or be sponsored by the US Army would allow artists every once in a while to pop in for residencies. But this is Myron Kruger, who's been doing essentially processors like hardware that would process video signals to be able to pick background and foreground and annotate elements and essentially create experiences. So even though this started like in the 70s, you can see how a lot of the stuff that we see nowadays has its roots a couple of decades ago. The intentions are definitely there. The technology is different, and the limitations, as you can see, are very visible. But the thinking behind it has a rich history. So it's easy to see how something from the 70s relates to other projects, like, for example, Memo Acton's body paint, which people might have seen either online or in presence, been installed in many, many galleries and museums of time. Similarly, Daniel Hirschman, who runs Hirschman Studio, where I've been working, has the project Engine 26, which again uses computer vision to detect outlines, looking at what's the difference between the current frame and the previous frame to detect the outlines, which then drive digital paint patterns. So the interesting thing about this is that the computer vision part is only such a small piece of the project. The bigger piece is around the different types of paints, the painting styles, and the different ways of scheduling the data and creating as much variation as possible. And the interesting thing with Engine, as opposed to other pieces I've seen around that time, is again, I guess more of a nerdy detail of how well it's integrated with other tools. So there's engine26.net, a WordPress website that basically captures the data, and when the installation is in use, data is uploaded, screenshots and images, and or high resolution prints can also be derived from the system. So this is basically looking at probably the simplest, most common pipeline of doing anything in terms of computer vision, which is essentially do segmentation. That's a very nerdy term for doing the difference between what is background and what's foreground, what is an interesting element to pick up in an image, and what is just noise that should be ignored. And once segmentation is done, then you can do a little bit of filtering to clean up the data and convert pixels to paths that can then be processed into further shapes, or it can be used for many other tasks. And I need to mention a little bit deep neural networks, because right after 2010, like 2011, 2012, there's a major breakthrough because of all these changes with having more compute power, having all these social media websites where people just upload loads and loads of images, so a lot more data. It just allowed ideas that started in the 70s. I believe Geoffrey Hinton's first published paper was on computer vision as well, trying to do human pose estimation. A lot of those couldn't have been, it was very, very hard to achieve any of the results that we can now take for granted nowadays with all the resources available. But going into, going into some more projects and talking about why and how to use computer vision for art installations or creative projects more, and maybe talk about, I'm going to talk a little bit about a technique. This is Joy Jacket. I'm actually going to run the video and leave it running in the background because I think it does a better job than I can at explaining what the project does.
Hey, George. There's no audio on your video coming through.
Oh, sorry. How do I?
I'm sure it's a Zoom setting, but if you want, we can link the video later. And people,
okay, that's a good point. I'm not sure if does this do it?
Nope.
Okay, maybe I'm just gonna talk over it and kill the audio.
Yeah, sure.
Apologies for that. I had no idea.
It's okay.
So hopefully this is a fun project to look at. I know it was quite a joy working on this one. There's only one section that uses computer vision, and that is a camera that is hidden. Actually, I should have paused. I'm gonna skip through. Yeah, that's a pretty good shot. The little hole over here that's the camera hole where there's a little Pi camera hidden, and it connects to the rest of the system. The point of this camera was to detect when somebody gets chocolate from the pocket, and when when the person starts biting on the chocolate. And at that time, this project is actually quite old. This is 2013, I believe. And that was the first time I used the Pi. I had to use the OpenCV C API, which is not fun to use back then, but it was the fastest way to detect things. And I learned a few things the hard way in terms of how complex some computer vision tasks can be and how deceivingly simple they make themselves appear. So the main challenge was detecting this wrapper with two variants of it, indoors and outdoors, which was more difficult than I thought. And there's two main reasons for that. One is lighting is probably the most important thing in computer vision. Everything that any algorithm that you end up writing first depends on the data that you give it, which relies on the quality of the image you can get from the camera. The problem with supporting any lighting, indoors or outdoors, is that outdoors, for example, it can be a day where it goes from nice blue skies to cloudy to dark. So the lighting changes them dramatically, which changes how everything looks. So the pixel values, if you will, they would change. So when looking for certain features, let's say certain edges or color combinations on the wrapper, it'll be much harder to detect. The added bonus on me learning the hard way, how hard it is to do things outdoors as opposed to indoors, where probably the light can be controlled and it's a much, much simpler environment, is that the wrapper in this particular case was shiny, which means the lighting would change even if it was indoors, based on the angle of the wrapper, all the colors would sort of change the way they look towards the camera. So that was a sort of a tough lesson for me in terms of how not to overcomplicate things. And we ended up doing a much simpler cheat or workaround for the detection. And you notice that there are LED strips on the cuffs. So what I end up doing is I've used the webcam to do a purple light detector. When you end up retrieving images, you either get them in from a camera. You can retrieve images as RGB, red, green, blue, or YUV, whereas Y is luminance or brightness, and U and V are combinations of other color channels. The advantage in this case is the purple light would fall onto the V channel, so therefore I could filter out specific sort of wavelength of the LEDs with the purple gel on top, which cut out any other lights like direct sunlight, or if I would shine a lamp directly into the camera, that would become invisible. It was only the purple LEDs that would be detected, which made the system a lot more robust. So the story there is the simpler the better, and indoors or controlled lighting preferred. I'm going to jump to another fun project. This is a TV commercial. I'm going to leave the TV running. Yeah, I'm going to leave this running without audio since the audio doesn't seem to be going through. This is for a drinks brand. The commercial was shot in Johannesburg in South Africa. And the whole project was actually pretty mental. If I try to describe it, you might think I'm high or something. It's essentially a massive cube cloud that has robotic musical instruments that get controlled by sensor stations on the ground. So it's this massive, I think it was 10 by 10 by 6 meter, 2-ton metal structure. If you can picture a Minecraft-like cloud, that would house 6 transparent boxes, and each box would have a musical instrument. And on the ground, there would be separate sensors. So these sensors would be a different kind. Would be a heartbeat sensor, a voice, the microphone would be a way to sense, a floor pad where you can. I'm actually going to pause on this previous frame because I think it does a pretty good job at showing the installation overall. So on the ground, we can see the input stations, like where we got the sensor data. This gets sent to the outputs, which are these musical instruments throughout the whole structure. So this was the version that simply played back the recorded data, and or it could be toggled to do live inputs. But there is also the project was also installed in Windhoek in Namibia, and it was running live with people interacting with it. So it's quite interesting to have a transition from something that can be controlled to something that's completely in people's hands. So yeah, this is a pretty mental project. One interesting thing about the project was also the fact that out of all these crazy input stations, maybe not all of them made it. One of them, for example, was a human hamster wheel, which for safety reasons, the concept was kept. Or we did have human-sized hamster wheel built in the studio just to test. And in terms of computer vision, there is only one part of the project that used computer vision, which is the soft surface. So I'm actually going to go back to the video over here. Probably should have put some sort of video bookmark. Oh yeah, this, which is a very simple interface. Essentially, as you move your finger on top of a piece of cloth, a soft surface, and that becomes an input to whatever is mapped. So you can control string instruments, for example, where on one axis you control which string, which note, and on another axis you control how fast motor to strum this string. And the way that was done is actually just using a very simple technique. So again, I mentioned segmentation earlier in the presentation. This is an earlier prototype. This is simply just a webcam inside a box looking upwards with the translucent cloth on top. So just doing the simplest filters I mentioned before, a little bit of blur, erosion and dilation, which cleans up the data a tiny bit, and thresholding, that's enough to segment a little bit of data, which you can see as circles below. So it's not the most intuitive way to build, like, if you will, a multi-touch interface. It's just having a play with having the right kind of lighting and settings and basic filtering can actually get some pretty decent results for playful interfaces. This is a top-down test. Later on, we end up doing something even simpler than this, which is just do the thresholds, pick out the peaks above, and we know the boundaries of this cloth. So whatever goes beyond, then that becomes the depth, and whatever is on x-axis can be mapped to a musical instrument. So that's taking two positions, two parameters. And the way this is done after the filtering is simply do a convex hull. So basically find the points, the smallest amount of points that become the perimeter of the shape, and then just pick the shape with the highest Y value. So these are examples of how very simple techniques can be used effectively. Same technique I've used to basically do background segmentation and just track blobs. This is a collaboration with a friend. His name is Christian. He's an artist currently living in Hong Kong, and he's had all sorts of crazy projects. I remember when we met a number of years ago, he built a TV made out of TV remotes, and you need to use the infrared goggles to actually watch TV, which is pretty interesting. This is his artistic exploration, looking at the concept of phase space, which is an idea that comes from physics, and sort of looking at traces of objects. What would, if you have a number of particles, what would be the total space that these particles could move in? And the way this is done is using 360 mechanical balls. They're not controlled whatsoever. So they're simply spheres with batteries and motors. Once you turn them on, they just roll, and they roll randomly. And this is what the software does. So this is looking at, it's just a top-down camera, looking at the motion, subtracting the background, and drawing a mask on top, revealing the video. So it just creates this abstract paintings, abstract drawings, the paths over time, and the paths would be random because it's a very analog process. Wherever the balls would land and how they would collide with each other, it's very hard to, yeah, it's a very good way to generate randomness. And I'll finish up on one more project, which is Stop Smile Stroll. This is a commission for Playable City. Playable City is a competition that runs in multiple cities around the world, and the artists that win this competition end up to do an intervention, a playful intervention in a city throughout the world. This one was in Bristol, and what it is while you wait to cross the street, you have the option to, you're walking with an arcade button, as you would, and a camera would pick up your facial expression and initially would display one animation, and then it would pick up the overall mood of multiple people that interacted with the system to display yet another animation. And two of these custom-made circle LED panels would be installed on opposite sides of the street, and they would send the data from one to another. And apparently I haven't learned my lesson of trying to avoid computer vision in outdoors, in public, where the lighting is quite tricky to control. The other challenge we had is this is fixed on a pole. So if I'm going to freeze frame here, the camera is actually hidden over here, and that's the button. Then the other challenge is that the camera angle is fixed. So initially what I started with is looking at facial landmarks. So looking at using a library to look at points around the face and use that to classify, to determine, like given a bunch of examples, what's the overall expression? Are people smiling? Are they frowning? And so on. And the problem I had with this approach is because of the fixed camera, the outline of the mouth would look different based on how tall you are. So let's take a neutral expression, the straight line. If a kid would be detected, the head would be a little bit low. So from a lower point of view from the camera, the flat shape of the mouth, the neutral expression, would look more like a smile, would get a curvature in one direction. And the opposite would happen for somebody that would be tall. The neutral face would start looking more like a frowny face. So this, to get around this, I've tried multiple ways of filtering, tweaking the data, removing rotations, and again, it got too complicated. And that's the first time I ended up using a convolutional neural network, which essentially means taking loads of example photos in a data set. I believe I had about 8,000 pictures overall with different facial expressions. And what the network would do is look at these examples, try to generalize data out of it, And when I gave it a new image, it could then infer, it could detect one of the few classes that I had trained for. And at that time, it was challenging to get into TensorFlow and learn how to train models and get all crazy with command line. But nowadays, it's much, much simpler. So yeah, I think that's where I'm gonna pretty much end my ranting. Hopefully these projects were fun and interesting for you to see. It's definitely easier to get started with things like this nowadays than it was a while back. So I can point you to a couple of projects, ML5 being one of them, which it's a JavaScript library. It can integrate with Canvas and many other things, but all these things that are so hard to do, and you need to kind of, I don't know, get a lot large data sets and do your own training, get comfortable with command line and whatnot. Now it can easily be done with a few lines of code, from like pose detection to facial landmarks to detecting objects in images and so on. So, oops, okay. There we go. I'm gonna quickly jump straight to the end. ML5 is one of them. Runway ML is another one that is great. That's probably a better way of doing it, which is essentially a UI where you don't need to touch the command line whatsoever. You can download many, many models that do all these clever computer vision things and more. So mask elements, detect poses, facial expressions, and whatnot. And of course, there's creative coding toolkits now. So in processing, open frameworks, and there are many other toolkits that you can interface easily with OpenCV. And I personally am interested in making this even simpler. So for Runway, this is my cheeky shameless plug. If you're interested in this, I built a processing wrapper for it. So these are some examples that are part of the library. You can just install Runway, install the processing library, and just run the examples. And in terms of computer vision, these are relevant ones. So dense pose is a model that essentially builds a UV map of a pose. So you can remap another person on top of a person, or you can mask, or you can do the facial landmarks, can detect objects in a scene, can detect objects with descriptions or describe the scene altogether, infer depth from a single image, which was impossible before. You had to use something like a Kinect or a stereo camera, or segment the scene into elements, like table gets one color, people get another color, which can be used for many interesting effects. And the second shameless plug is I was lucky enough to be part of the Processing Fellowship 2020, and I'm going to be focusing on OpenCV integration with processing and v5.js. So if anyone is interested in playing with that, reach out. And as I release materials, it would be great to get people that are interested to do tests and provide feedback. Things are easy enough to understand. If they're too easy or too hard, it would be good for me to get a feeling. And that's me in a nutshell. I'll be standing by for questions. I'm on Twitter, and these are the accounts for companies that I work with in the past, all great people. And thanks so much for your time.
Awesome. Thank you, George. That was, yeah, really interesting, man. Thank you. Yeah, I think we've got a few questions in the channel. I'm just going to ask a very quick one. It's a two-part question. Are you hiring, and do you have any remote jobs going? It looks like a lot of the work you do is quite fun.
It's a tough one. So I don't think hiring is happening at the moment, as far as I know. Most managers, they do have a freelancer list.
Yeah.
They do work with freelancers, so it's more, the studio is actually, there's a 10 of us, it's a small studio, but we do have 30, 49 people on large projects. So currently we have there is a network of freelancers, but then there's people just get in touch and provide their portfolio, you can add it to the list, and it's, the projects are pretty much relevant. That's one option. And besides words, at the beginning of the year, actually looking for generalists or programmers that are really good at Python, C++, advanced concepts, computer vision. At the moment, because of COVID, things are a little bit on pause, but hopefully once things get back to normal, I'll get back to them becoming a bit more.
Yeah. Cool. Anthony, you there?
Oh, I turned off my video to save my internet.
Oh.
Yeah, we've got some questions from YouTube. David Adam Thompson says that he loves all your commercial projects, and he's just wondering what's your favourite one, or which is your favourite project in general.
Fun project to work on. I wouldn't say I've got a favorite project per se. I've got a favorite project per technique, I guess. For like, there's different reasons for different projects. For example, I like the facing of the Joy Jacket project, even though I had to learn the hard way a couple of things. With Vigo, I liked how much you can do so little with something like just Raspberry Pi's low power devices and simple techniques that achieve experiences that are actually quite rich and engaging. So I don't have one kind of favorite project, but I do have many favorite projects overall.
Another one from YouTube is from Michael Brewster, and Michael is interested in knowing about your educational background. Did you study a course, or are you self-taught?
It's a little bit of both. I was I graduated from the creative computing course that was running at Goldsmiths. Hopefully it's still going. And I did a master's at UCL in adaptive architecture and computation. That's probably renamed now. And well, at Goldsmiths with creative computing, that's how I got introduced to things like open frameworks, OpenCV, and creative coding toolkits like MicroSP and processing and whatnot. So it's part of that, but obviously learn a lot. I've learned a lot on my own, and I think that's like the best way to learn is that way. Whereas education is very helpful. I would say maybe do as much as you can on your own and use the precious time of the tutors to just steer you and guide you and show you all these cool things that you might have not encountered on your own. For example, learning about signal processing, vision and perception, like vision. How does vision work? How does hearing work? And seeing the rich history of that in computer science was very interesting for me. Hopefully, I covered the question.
No, I think that covers it really well. Okay, we're going to try something. We haven't tested this before. We're going to take a question from Zoom. So I'm going to unmute them now. Hopefully, they don't say horrible stuff. Take it away.
Hi, really good presentation. I'm just curious about your decision to leave. Why did you leave Hirsch and Mann? Because it seems like most of the top projects you talked about are from Hirsch and Mann. And then like now that you're at Disguise, and Disguise as a post is very focused, like software oriented debugging, like hardcore coding. Like why did you change your career in that way? And do you miss working at Hirsch and Mann?
Drew, you really put me on the spot there. It's a tough one to answer. So it's probably from my presentation it's obvious that it was not an easy decision, but it's at the back of my mind. I've been sort of like hacking things or doing things, not in a very professional manner, but more like a self-taught, getting things done last minute, figuring out things on the fly way, and always I never spend the time to get the experience to do proper software engineering in an engineering team, and I want to focus more on computer vision. So in a way, it was chasing a different goal. So in a weird way, if I see myself doing computer vision as my day job or like doing software engineering the proper way, then I know for sure that I'll be able to kind of hone in on focus on one thing, as opposed to being very, very spread out over many, many things, which is very, very fun. And I do miss it. But I just, at that time, I felt the need to focus on one thing at a time and hopefully get really good at one thing and then figure out what I want to do next. hopefully that covered that.
Yeah, thank you.
Andy, do you have any more time for questions, do you think?
There was just one more on the Zoom chat there, just asking if George has a blog or anything along those lines that you can share, or are you all about Twitter, or how how do we keep following what you're up to?
Yeah, so I do have a website. I've got a screenshot on there. Peckin Pixels. Thinking of the thing is Unported. I've got probably already seen that button. And otherwise, you'll find me on
Twitter, and I guess GitHub and Stack Overflow. This is my nerdy way of doing social media, I guess. And yeah, so these, and if you're interested in the project, like I wouldn't have been able to work on all these crazy things unless I was part of a great team that makes all this possible. So it's only like one tiny little cog. So if you're interested in the project, I do recommend checking out the companies as well and seeing other projects.
Great stuff. Yeah, nice one, George. Thank you so much. It's really inspirational. Yeah, nice one. Well, I was actually planning to have a little clapping track, but I completely forgot. So anyway, we're gonna have a quick break, and then Cassie's gonna enlighten us on some SVG magic that she's been working on. So this takes sort of 5 minutes, and then I'll see you back here. Right, I think we're back on the YouTube stream now as well. So welcome back, everybody. We have our final speaker, Cassie Evans. Give us a little talk about some SVG tips and tricks on how to kind of make things a little bit more interesting for us all. So right, over to you, Cassie.
Cool. Do I just share my screen then? Is that working? Yeah. Awesome. I'm surprised that I still know how to talk after all of this being quarantined at home. But it's nice to see some faces. Yeah, I hope everyone's doing okay. So yeah, I'm going to be talking about painting with SVG today. So apologies because obviously we're streaming this, so I've got a few little animations. They're probably going to come across as like 5 FPS or something. But I'm going to link to all the code pens afterwards, so you can go and check them out on the internet, where hopefully, as long as you look at them in Chrome, they'll work. So yeah, painting with SVG. So my name's Cassie. I'm from Brighton in the UK, and I like making kind of creative stuff with my computer, I guess. It's not always with my computer. I always have liked making kind of creative things and tinkering around with stuff. And I used to draw a lot when I was younger. This is one of my earliest masterpieces. Just drawing all over myself with permanent markers. So my mum was probably not very happy about that. And when I was younger, when I wasn't drawing on myself, I was usually taking things apart as well. So kind of breaking things into pieces and trying to figure out how they worked. So I don't have any photos of that because one of the things that I used to take apart was my dad's camera. So no photos. But yeah, that's kind of me in a nutshell. I like drawing and I like creating stuff, and I like kind of tinkering around with things and figuring out how things work. So yeah, naturally, when I kind of grew up a little bit and realized that you could tinker around with computers and you could make stuff with code, that was kind of me hooked. So this is my old Neopets page. Yeah, I really loved Neopets. It's kind of how I learned how to code. And how I started making things on the web. I used to have a little business in primary school where I would swap Neopets pages for donuts from the tuck shop, because my parents wouldn't give me tuck shop money. So I'd always like have tons and tons of donuts, which was great. So yeah, nowadays I make websites for a living, as I'm sure a lot of you that are watching do. And I make those websites for actual money, not for donuts anymore, which is a shame, because I think that the websites that I made back when I was exchanging websites for donuts were actually like a lot more fun. And capitalism tends to get in the way of creativity. And I think the web nowadays has got really boring and corporate and flat. And I liked it so much more when it was like early on and it was a bit of a mashup art experiment. I don't know if anyone's seen this website. It's excellent. It has audio, but I think I've got that muted. But yeah, if you miss the web being fun, go have a look at this website because it's amazing. Remember FTP and Blink and jQuery and cursors with aliens on, and GeoCities and all of that kind of stuff. So yeah, that's kind of my inspiration, I guess, is the web back when the web was terrible. So I spend a lot of time on CodePen, and I make a lot of things contributing to making the web a little bit more terrible or a little bit more fun, kind of depending on how you look at it. And I really love making stuff with SVG because it's like a markup language and an image format at the same time, which is really awesome if you're into drawing and coding, because it's like in between the two things. And it kind of feels to me like that old like web magic, because it's a markup language. It's kind of like those like blink tags and marquee tags and stuff that we used to have. So yeah, code-wise, SVG is just markup. You know, like it creates vector graphics, but it's just markup at the end of the day. So as anyone that's been on Twitter and heard the programming police, like markup is not a real programming language. But, you know, I think that that's the best thing about SVG, because it's an image format as well as code. And it's markup, it's like HTML. It's kind of accessible for designers and for developers. And you don't have to be like a super rock star programmer to get started. So it's like a really fun jumping off point for creative coding, in my opinion. So this very good quote is not by me, this is by my friend Rich. He referred to SVG as an alternate universe version of HTML focused on graphics instead of documents. And it was better than my description of SVG I had at the time, so I stole it. So that's my description of SVG now. And yeah, because SVG's got a DOM and you can kind of put it into web pages, it doesn't just exist in isolation. You can manipulate it and you can animate values with like CSS and JavaScript and stuff. So this is a little chameleon that I made, and he changes color when you hold different things up to the webcam, which was really fun. It's kind of, I think that it's just like a really fun way to learn new things and experiment and explore, rather than making like endless to-do lists and stuff. Yeah, and then this is a little blobby guy, and he dances, but he only dances when you're not looking at him. He's really shy. So if you cover your face, he'll dance, but if you look at him, he'll stop. And it's a lot of fun animating with SVG on the web, because you can play around with like libraries and browser APIs and user interaction and all of that kind of stuff. But art-wise, there's kind of one thing that really gets to me about vector illustration, and that's that SVG is really flat. Like you always see the same flat illustrations on the same flat looking websites. Flat, flat, flat. And you know, it makes sense, because vector graphics are maths. Like it's logic. Computers like straight lines. It's easier to render. It makes sense. But like, I really love the messiness of real life art. Like real life art feels really human and tactile. These are some pages from my cousin Jim's sketchbook, which is probably one of the my favorite things that I own. And yeah, you definitely go check out his art. It's completely ridiculous. But I really love sketchy art like this. I think it's got such a good kind of human quality. So yeah, do vector graphics have to be so flat? Can we recreate some of this texture with SVG? So obviously we can, because I'm doing a talk, and if we couldn't, then the talk would be over. So yes, we can with SVG filters. So filters are super cool. They kind of work like filters in Photoshop or other graphics programs. And there's like a bunch of filter primitives that we can use to create different graphics effects. So these here are filter primitives. And then those filters can be applied to HTML or SVG elements. And filter primitives, they live inside a filter element, and then they apply graphic effects to either a source graphic or source alpha, or like the output of another filter primitive. So that sounds quite complicated, but it's quite a lot like audio processing. So filters have inputs and they have outputs. So the output of one filter primitive can be passed into the next one. And you can also pass in like source graphics or alpha channels, and then you can manipulate those. So because you can include so many different filters in so many different ways, there's like infinite possibilities, which is really exciting. And these two filters in particular, they're really fun when you use them together, because you can use them to create kind of distortion effects, which is really fun. So yeah, the turbulence filter, that's this one here. We can use the turbulence filter to generate Perlin noise patterns. And I mean, you're a creative coding meetup, so I'm sure a lot of you have come across Perlin noise before. It's basically just pretty random noise. They use it a lot for game development. So you can see here, if we change the base frequency of the Perlin noise, the lower the base frequency, the larger the patterns are. And then the higher the base frequency, the smaller and kind of more detailed the patterns are. And there's a really good article on Codrops by Sarah Swadan about SVG filters, if you kind of want to dig into a little bit more. So then, yeah, once you've got this kind of noise pattern, you can use the displacement filters to create distortion. So when you use them both in conjunction, like the displacement filter, it takes the color information from the turbulence filter, and then it uses that to distort something that you pass in. So in this case, we're passing in, this is a lie, it's not a source graphic. We should be passing in source alpha of these squiggles here. But yeah, we're passing in those squiggles and then we're distorting them with the filters. So yeah, if we kind of use these filters and set them to the right values, we can use a combination of them to create these realistic looking pencil effects. So you can see if we change the base frequency, like the detail of the Perlin noise changes. So we've got quite big patterns here, and then we've got quite small patterns here. So if you get it at a good point, you've got this kind of pencil texture. And then we can change the scale of the displacement filter to kind of create this noise effect and create these rough edges, which is really cool. So you can kind of generate different pencil textures with SVG. There's a guy who's written a blog post, Scott Turner. He wrote this amazing blog post recently about using this effect to create hand-drawn maps in SVG. So if you want to kind of dig into all the different pencil effects, like read that blog post, it's really good. And yeah, you can also animate SVG paths. So that's really cool, because we can create paths that look like pencil drawings, and then we can animate them to create handwriting effects. There's a really good article on SVG line animation, which I've linked to here, but it's basically just using stroke dash offset, which is kind of a dashed path. If you dash a path and then you move those dashes along, it kind of looks like the line's drawing in, which is, it's a bit of a hack, but it's very cool. Do it one more time. Yeah. So yeah, that's really cool. But it's, you know, it's not very detailed. Like if you look at these lines, they're just one set width all the way along. And that's, you can't really do variable width strokes with SVG yet. I think it's coming, but you can't do variable widths at the moment. So it doesn't really look too much like a real handwriting stroke. If you were writing in real life, you've kind of got variable widths and scratchy effects and stuff like that. So we can kind of fake this by using clip paths. So what I've got here is in Illustrator, I wrote out this quote, and then I saved out the text as a mask. Well, I saved it out as an SVG, and then I'm using those SVG paths as a mask, or a clip path, one of the two. Let me have a look. I can open it up so you can have a look. So yeah, here we've got the path that's animating is inside this group element here with the pencil filter applied to it. And then we've got a clip path, which is in here. And the clip path is the text outline. So if we take the clip path off, you'll be able to see the stroke that's actually animating. Yeah. So it's not as jazzy without the clip path. It's just a single stroke that's animating. But then when we add the clipping on top of it, it's kind of masking all of the outsides of that stroke. And then it looks like we're doing an actual kind of text animation with variable widths, which is really cool. So yeah, like using stroke animation and filters and masking or clipping kind of all together, it's really amazing what you can achieve. And another cool thing that we can do with turbulence and displacement filters is a thing called squiggle vision, which is a really amazing name. So squiggle vision is like a traditional animation technique where hand-drawn animators would loop 5 slightly different drawings. They'd loop them together in a sequence called a flick. And then it creates this kind of sketchy hand-drawn animation effect. And we can recreate this effect with SVG by kind of rapidly iterating through a few different filters with different displacement settings. So this is a little jellyfish that I made. And the base frequency is changing so that it looks like he's kind of wobbling around, which is quite fun. So yeah, you shouldn't really animate filter properties directly because it's not very performant at all. You should basically avoid animating anything that causes a filter to recalculate itself. But what you can do is you can create several different filters with different displacement values. And then you can just iterate between all of them because then they only get calculated once at the beginning. And it's a lot better for performance that way. This is another one that I really like. This is by David Corsid. It's got that like squiggly animation technique and it's just adorable. Yeah. So yeah, we've done loads of pencil effects and kind of sketchy edges and stuff. And pencil effects and sketchy edges are cool, but how about paint effects? Like, what about colors? Because, you know, this is fun, but all of the colors and like the filled areas are still really flat. Like it still kind of looks like a vector. So how do we get that kind of hand-drawn thing? So yeah, in order to do this, we're going to have to get some color involved. So we have to introduce another filter. And this is probably one of the filters that looks the most terrifying. It's FE color matrix. It's basically got a big grid of values, like matrix values. The first column is the reds, and then greens and blues and alpha, and then the last channel is a multiplier. And it goes the other way along as well. So like horizontally, red, green, blue, alpha, and then red, green, blue, alpha, multiplier. So the values that you can see that are green here, the first one is the reds in the red channel, and then we've got the greens in the green channel and the blues in the blue channel. So that's kind of how you manipulate color values in FE color matrix. There's also this great chart that Una Kravitz put together. So this kind of explains it a little bit better. But also, if you're looking at this and you're like, oh, I don't know what this is, I just want to make things that are different colors. I built a FE matrix, a hex to FE color matrix converter. So it was basically because I got tired of having to do that by myself when I wanted to do like icon color changes. So you can just put in a hex code, ta-da, and then you get your matrix values there. So you don't actually have to worry about it. You can just copy and paste those values. got you covered. So once you've got your colors out of FE Color Matrix, then we can do cool paint effects. And it's using a lot of the same techniques that we were using when we were doing the pencil stuff, but just like a little bit more involved. So in order to create this, we've got the same thing. So an SVG with a defs tag. A defs tag, by the way, that's used to store graphics elements that are going to be rendered at a later time. So not rendered immediately when the SVG loads. So anything like filters and clip paths and masks and all that stuff goes inside a defs tag. So yeah, we've got a filter. The first one, we're creating some fractal noise, just like we did with the pencil. And then we're creating displacement. But with the pencil, I think we were using like 4 as the scale, whereas on this one, we've got like 400. So loads of displacement, which is why we've got all of this like randomness and holes and stuff in it. And then using the color matrix to tint the noise and up the contrast. And then the last filter is just a composite one. And we're kind of putting the source alpha, the colored noise, and the blobs all together and kind of blending them so that we get this output. So yeah, that's paint effects with SVG, which is really cool. And also, you can apply those paint effects to strokes, and then you can animate those strokes like we did with the pencils. So you can create painting effects with strokes and filters. And I've only just figured out that I can do this. So I really want to create some sort of generative painting thing where you just get random paint drawings everywhere. I think that would be really interesting. Yeah, and then if you put all of those techniques together, then you get something like this. So this flower, the actual strokes are kind of pencil strokes. There's like a kind of scratchy, I'll open it. Yeah, there's a kind of scratchy squiggle vision thing going on. And then we've also got the watercolor brush effect and the masking over the flowers. And I think that's the cool thing about SVG, I think, and SVG filters and all the stuff that SVG can do. Like it's limiting, but you have this small amount of different things that SVG can do. And you can kind of put them together in different ways and create really cool things. And I think sometimes when you've got a blank canvas and you're trying to make something and you're trying to be creative, it's quite nice to have a limited tool set to work with, because then it's less about like, what am I going to do? But it's more about how can I utilize these things and create something interesting with them. So yeah, that's painting with SVG. I hope you feel inspired to have a play around with some filters. And if you are, I'm going to tweet out like a template pen and a collection of all of the pens that have been in this talk with some example filters in for you to get started. But I'm also going to leave you with this disclaimer, because when I was writing this talk, I was like, I'm pretty certain I understand SVG filters now. And then I completely broke one of my demos and I had absolutely no idea why. And I told my friend and he said, can they really be understood? Or is it more like a wild horse thing where with enough time and mutual respect, they might let you along for the ride? And I think it's that. So if you're playing around and it doesn't go your way, just remember wild horses, just give it time and respect and they might let you along for the ride. So cool, yeah, thank you for listening. You can find me on Twitter at Cassie Codes, and you can find me on CodePen at also Cassie Codes, but with a dash. Yeah, thanks everyone.
Yeah, great stuff, Cassie. That was yeah, really inspirational. I know I kind of written off SVGs a little bit for, I guess, as just sort of being good for data viz and charts and that kind of stuff. So it's really cool to see it taken to a whole nother level. So yeah, really cool. Anthony, you there?
Yeah.
All right.
Still here.
Is there any questions going on there? I'm seeing like loads of like comments and stuff going on.
Me though, you mentioned Neopets as a place where you first started to learn to code, and I've had similar experience with like MySpace, and I know other people have had that. Do you think there's like a Neopets MySpace equivalent now that's good for people to get started with this stuff?
I don't think that we have anything that's that accessible for beginners now. It's kind of a personal bugbear of mine. I think that like Glitch is the only thing that I know of that I think is kind of similar. It's got that community and that creative spirit, but it's, again, you have to have already learnt enough to kind of get going with it. There's not really anything that I know of that exists at an accessible newbie level. I really like SVG for that. Like I've been coaching a meetup called Code Bar for quite a while. Like I used to run it, and for a lot of people that were coming along that were trying to learn how to code, if they were a little bit more visual, we'd kind of give them SVG stuff to play with, because it's kind of got that fun, accessible for beginners aspect. But yeah, I really miss the days of Neopets and MySpace and stuff.
Yeah,
it's great.
Got some actually from YouTube now. Everyone's like starting to ask. One from someone called Charis. They said, do you ever get to use these techniques in commercial projects? What's the preferred? Do you ever get to use these techniques in commercial projects?
Yeah, I do. So one of the good things about SVG is that it's good for like progressive enhancement. So you can create animations with SVG, and then if people don't have like JavaScript or they don't want animation, then they still get like a graphic. It's not like Canvas where it's like animation or bust, and it's just like a black box that it falls back to if it fails. And it's because you can kind of mix it in with HTML DOM. You can create like submit buttons that have a small animation on. There's a guy, Adam Kuhn, who's making amazing, probably not very commercial, but amazing things with like form submits and stuff on CodePen at the moment. He's got one where you put in your email and it shoots it off into like a roller coaster. It's brilliant. But yeah, SVG is great for stuff like that, like really from really small things like icons to like infographics and illustrations on websites and stuff.
Do clients like ever ask for that specifically, or do you sneak it in?
I usually sneak it in. Yeah. And then if you sneak it in enough, then they start asking for it.
I see. Another question from YouTube, Valstorm again. Did you look at any other paint styles like oils, acrylic, that kind of effects?
Yeah, I'm busy trying to get an oil painting thing working. It's almost there, but it wasn't quite ready in time. But yeah, I'm trying to get an oil paint effect.
Oh, that's pretty much all the questions.
Mute myself from the YouTubers. There was one from Mike Blomberg. Do you use libraries like GreenSock for animation, or any other animation libraries of your preference?
So I use GreenSock mostly for SVG animation. I think you can use CSS for a lot of animation. I really love CSS for animation, but SVG has some browser corrupts. Like there's quite a lot of issues with like transforms and how it gets handled cross browser, and GreenSock kind of handles all of that really nicely. So you can do it with CSS, but you'll be saving yourself a lot of headaches if you use the library like this.
Yeah, cool. And actually, on one of the questions, someone asked about performance. Like I know for more sort of data-heavy things, I guess Canvas, or I guess the more intricate stuff, Canvas for a while was sort of the preference. Maybe still is, but do you find any issues with performance stuff these days?
SVG does have performance issues, so I think that if you're animating a lot of different things, like if you're doing something like Jenny's game, that's amazing, that would not work in SVG, like your laptop would be taking off. Like SVG is very good for short animations that aren't looping, animations that are only like animating a couple of different elements. It's mostly because they're not hardware accelerated in Chrome at the moment. There's a bug there to fix it, or an issue even to fix it. But yeah, Canvas is still better for animating lots of things.
Cool. Yeah. Amazing stuff. Thank you, Cassie.
Awesome. Thank you for having me.
Yeah. Right. That I think is all for now. Yeah.
Cheers.
Cheers, guys.
Cheers.
Yeah. So we're going to leave it there for now. Thank you all for joining us. Normally we run these every 2 months ish when we are not locked up at home. So we're going to attempt to try and do these a little bit more frequently now that we have like this unrelinquished power that we've not had before. Yeah, if anyone has anything cool they want to demo or talk, we've got a sort of a list of people that we're sort of slowly working through in terms of people who are keen to speak, but I think we should probably take advantage a little bit of not being limited to London. Anyone here that normally can't do a talk or do a demo in London, we'd love to get you involved even more. So we want to sort of, try and spread this out a little bit and not limit this, just to ourselves in little London here. So yeah, get in touch. We also, when we do stream or when we do our meetups from the BBC, normally we do live stream, or we've just started live streaming. So if you're not a member of our group, do hit that membership join button somewhere on there.
Yeah, I don't think there's an equivalent like or Meetup.
No.
Hit the join button.
Hit the join button. And we'll I think for a little while we'll be doing these remotely. Hopefully see you at the next one. So thanks, guys. We're going to unmute you all on the Zoom channel right now. So you can, you've all been released and can chat away amongst yourselves. Cool. Thank you all, and
Thank you.
see you soon. Thanks, Cassie.
Thank you so much. That was loads of fun.
Cheers.
Thank you. Bye-bye.
Bye.
This is a weird chat. Everyone's just saying goodbye.
How many people are here?
Not any, they're all gone now.
Everyone's leaving. Bye.
I'm sorry. Holding slide down. Holding slide. Yes.
Bye.